Hello. So, in the last session, we defined our steps. Steps that is the core of portfolio management, right? Let's revisit the steps. The steps were step number one, find the expected return of an individual stock. Step number two, find the expected risk of an individual stock. Step number three. Now, this step number three is very critical. Step number three is very, very critical. Find the correlation, and you can also write find the covariance between the two stock. It's important because the whole portfolio management concept is based on this covariance or correlation. So, if you know how to calculate correlation and covariance, you know what is the rationale of the formula behind the correlation or covariance, then you are right. Uh, then you are at a right state or right place to start studying the portfolio management. But because a lot of student in this session would be very new and naive, therefore you need to understand what is covariance or correlation. Okay, in depth. It's not just the formula of summation of x minus x bar, y minus y bar upon n, and you get the covariance. No, this won't work. You need to understand why the formula has been derived in that way. So this is going to be a very critical discussion whenever we do. If we would be able to cover in this session, that's fine. But even the step one and step two needs a detailed discussion. It cannot be just rushed into. You need to understand that, okay, this is the way to calculate expected return. This is the way to calculate expected risk. Okay. So step three, correlation between two stocks. Step four, expected return of the portfolio. So once you understood how to find out the expected return of individual stock in the future, you would enter into expected return of the portfolio, then expected risk of the portfolio, and the last is the optimization. About the last step, I just want to utter. Even if I won't speak about optimization, but the whole portfolio management is about optimization. When we talk about efficient frontier, whether the efficient frontier, whenever I will discuss this word efficient frontier, whether I talk in the Harry Markowitz efficient frontier or CAPM efficient frontier, whatever I discuss, whenever I discuss, that discussion is about optimization because it's talking about efficient frontier. Okay. So even if we don't know what is the maths behind the optimization, because optimization itself is a very lengthy session, let's see whether we would be able to cover the maths or not. But definitely on Python, we would be able to understand it in detail. Cool. So optimize the portfolio where we'll try to maximize the return and minimize the risk. So it's minimize the risk. Let's write it down. Minimize the risk. Okay, so there could be possibility that first we put down a lot of time to just discuss expected return of an individual stock. So put down the heading and write expected return of individual stocks or individual instruments. Why this is a difficult discussion? This discussion is difficult because we are trying to predict the return of the stock. How would you be able to predict the return of the stock or any instrument? You don't have the crystal ball. You're a human being. You're not God. You cannot predict the future, right? You don't have like a kind of a vision to see the future. So the nearest thing through which I can predict is my maths, right? So there are two ways through which I can predict the expected return. Okay. One is actual prediction. Okay. Actual prediction. And I can do with the help of inferential statistics or right? Where, or you can say, I can predict with the help of machine learning or data science. Basically, I'm talking about something related to regression. A regression can predict, or different machine learning algorithm. Regression is just not a machine learning algorithm. Regression is a pure statistics. With the help of regression, with the help of this pure math, regression has a pure math. I can predict the future. Regression is a pure statistics through which I can predict the future, right? Or I can predict it with the help of machine learning algorithms. Machine learning algorithm does not falls under inferential statistics. So please try to understand that. But actually, we haven't studied anything related to regression yet. We haven't started regression. Definitely on this channel, there is a revision video on regression, but we haven't dedicated any live sessions on regression for this batch or this cohort. So what I need to do, I need to skip this discussion. And even in the curriculum is not interested in finding out the future return with the help of machine learning algorithm or regression. The curriculum is saying be basic and try to find out the expected return with the help of descriptive statistics. You don't have to remember this descriptive statistics or inferential statistics because this is not the part of portfolio management. Okay? This is the part of statistics, quantitative analysis. We'll discuss it there and then note it down. In descriptive statistics, this says that you have the data. Which data? You have the historical data. And with the help of this historical data itself, you would be able to predict the future. You would be able to predict the future. That is, you would be able to predict the expected return of an individual stock, or you can able to predict the expected risk of the individual stock. So just focus on the historical data. Okay. So assume you have a stock A, and the historical returns for the past date or the past month look like 3%, -4%, 0%, 2%, 10%, 15%, -8%. So this is the historical return. I think we have the historical return of 7 months. You could have the historical return for the whole year. It's up to you. Okay. So, or you take one more, or seven is fine. Now, what descriptive statistics is saying that just take out the mean of this data and that would be your expected return. Just take out the mean of the historical data, mean of the historical data, and that would be your expected return. This is what your curriculum is stating. But I'm trying to give you the logic that why your curriculum is saying that just take out the mean and give the expected return. There is a logic related to it. Because, and it's not mean only. It's not mean only. It's your moment one in descriptive statistics. Don't worry about what is moment one. And this is your moment one in descriptive statistics. What is moment one? Moment one are your mean, median, or mode. What is mean, median, or mode? What is mean, median, or mode? They are the central tendency of the data. What? They are the central tendency of the data. They are the central tendency of the data. Mean, median, mode is the central tendency of the data. Where my data lies on an average. What is the center of the data? So assume this is your data and you want to know the center of the data. That is your moment one. And you find the center of the data with the help of mean or median or mode. Okay. Now, when you get into the depth of this descriptive statistics, you will find that mean is the best linear unbiased estimator. What? Your mean is blue. Best linear unbiased estimator. Best linear unbiased estimator. Estimator of what? Estimator of the future. And therefore, most of the time, instead of using median or mode, we use mean. So it's not that we have taken mean abruptly to find out what is the expected return of the stock. There is a proper statistics discussion that will happen in the quantitative analysis discussion. Right? We are into portfolio management. Right? We are into portfolio management. So therefore, we cannot give a lot of time to statistics and understand what is descriptive statistics moment 1, 2, 3, 4. We can't do that right now. So we cannot enter into this discussion, but I'm telling you that when we discuss quantitative analysis session 1, then we discuss about moment 1 in detail, near about an hour, and talk about why mean is the best linear unbiased estimator to predict the future. Getting it? So now this is the statistics. Now come to the intuition. The intuition is okay. Sometime a stock is giving 3%, sometime it is giving -4%, sometime it is giving 0%, 2%, 10%, 15%, -8%. Where the return lies on an average. Where the return lie on an average. What is the center of this data? What is the average of the data? Feel it. On an average, the return of the stock is 3 plus -4 plus 0 plus 2% plus 10% plus 15% -8% divided by 7. There my on an average return of the stock lies. Let's do the maths. Let's do the maths. 3 plus -4 is -1 plus 0. 1, 1, 10, 11, 11 plus 15 is 26. 26 minus 8 would be 18. And 18 divided by 7 is 2 point. The mean of this data, understand, the mean of this data is coming as what? 2.5714. That is the mean of this data. Forget about the word mean. This is where my data lie on an average. This is where my data lie on an average. So what it's saying that this is your mean, which is 2 point, this is your mean, which is 2.5714. This is on an average where the data lie. But I'm not saying that every time the return would be 2.5714 in the future. The return may rise, may fall, may rise, may fall. Sometime it is 3, sometime it is 3, sometime it is -4, sometime it is 0, sometime it is 2, sometime it is 10, sometime it is 15, sometime it is -8, but it revolves around a mean that is 2.5714. That is the best estimate I can do for it because that's the mean of the data. That's where the center of the data lie. And therefore people use mean for expected return. But is it necessary to use mean? And this is specifically arithmetic mean. The formula that you have applied right now to find out the mean is actually the arithmetic mean. What mean? Arithmetic mean. Arithmetic mean, arithmetic mean formula AR or AM, arithmetic mean formula is what? X1 plus X2 plus dot 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 plus Xn upon n, and you will get what? Your arithmetic mean. What if I would have asked you to use geometric mean? Yes, you can use geometric mean, but see, I think in some of the examples they also discuss that you use the geometric mean. That's fine. Geometric mean is used to predict whenever there is something called as a growth. Okay. Whenever there is discussion about the growth, what is the growth of GDP, what is the growth rate of something, then it is better to use geometric mean. However, some of the student may argue that return and growth may go synonymously. And I would agree to that statement also. So yes, because of that thematic discussion, sometime people also use geometric mean to predict the return because the return is very much related to growth. See, there is arithmetic mean, there is geometric mean, there is harmonic mean. We know that. But you cannot use arithmetic mean everywhere. You cannot use geometric mean everywhere. You cannot use harmonic mean everywhere. You need to be very cautious whenever you are reading the book that what mean they have applied. Okay. Yes, again, I'm stating that arithmetic mean, geometric mean, and harmonic mean is a discussion of what? Statistics. Okay. It's a discussion of statistics. But whenever they are teaching you management, they are assuming that you know the statistics. The first book that you have read is statistics, which could be an incorrect assumption. Some people want to just jump into the portfolio management, but that's fine. So I'm taking arithmetic mean. You can also use geometric mean, which is slightly different. It is not very complex and different. It is slightly different. And the geometric mean formula is 1 plus return into 1 plus return 2 into 1 plus return 3, so and so forth. 1 plus return, let's write it somewhere else. So the geometric return formula would be, mean formula would be 1 plus return 1 into 1 plus return 2, so and so forth, 1 plus return n, and under root by the power of the number of returns you have. So if you have 7, the answer would be 7. So how would you calculate it? So geometric mean would become 1.03. Why 1.03? Because 3% is what? 3 upon 100 into 1 minus 0.4, which will make it what? 0.96. So 0.96, then 1 plus 0 is 1, then 1.02, then 1.1, then 1.15, and then 0.92, and then you take, after multiplication, you take 1 upon 7 because the number of entity that you have is what? 1, 2, 3, 4, 5, 6, 7. That's right. And that's give you geometric mean. I'm not going to invest a lot of time to how to calculate geometric mean or arithmetic mean because first of all, it is very basic. It is something that you have discussed in your class 9th or 10th, so I will not invest a lot of time there. But you should understand for your curriculum, you only have to calculate the expected return of the stock with the method of arithmetic mean or geometric mean. You need to look into your curriculum that how they are calculating expected return. They will never ask you to calculate the expected return with the help of machine learning algorithm or regression in this curriculum. But in the real world, yes, there are different methods to calculate the expected return of the stock. So now this is very important discussion. There is a difference between the syllabus curriculum and the real world. Now, if you are managing portfolio for yourself, yes, you can use the arithmetic mean to find out the portfolio management and find out the balance between the different stock. Okay, this is the weight given to the first stock, this is the weight given to the second stock, so and so forth. But yes, there is more robust method to predict the return. And I would say that whenever you enter into the real portfolio management for the starting, for the paper portfolio, hypothetical portfolios, you can play with expected return because I will not recommend you to jump into managing the portfolio without doing the paper investing. So whenever you are doing the paper investing, start with expected return calculation, which you have calculated with the help of mean. And when you get quite well versed, because it's not that you know the regression algorithm and you would be able to predict the future. No, that doesn't happen. You need to know what is the maths behind the regression. You need to know the details of the regression. You need to know the assumption of the regression. Otherwise, your prediction would be like completely futile, of no use. Okay? So with that, what we have what we have stated that if you want to predict the expected return of an individual stock, use arithmetic return or geometric return for the curriculum, but there are different methods through which you can do it. So the step number one is almost clear that we what we'll do will just do the summation and divide by n, or you do the geometric mean and you will get the expected return of the individual stock for this curriculum, not for the real world. Now you got the theme, I think, and if I talk about the expected risk of an, which is step number two, expected risk of an individual stock, then again there are two different methods. The way we have two different methods or two different school of thoughts that you can do a descriptive statistics or inferential statistics. The same way we have two different methods through which I can calculate the expected risk of the stock. One is definitely a kind of a predictive method. I won't, I won't be writing like inferential statistics, but yes, you can apply inferential statistics. In predictive method, there are different machine learning algorithm. There is a method called Garsh method, Arsh method. There are different methods, Garsh, Arsh. There is also a method which is called as implied volatility. Implied volatility. Currently, I would say this is one of the best method. Implied volatility, from my understanding, is one of the best method. But see, whenever you predict something, you cannot predict with one approach. You have to apply a different approaches to find out whatever you're predicting makes sense or not. At starting, definitely when once you have proved that your model is working uh, correctly, then you don't have to validate every time, but at least in 3 months you should validate your model. Implied volatility, I would say that one of the best approach to predict the risk. However, in your curriculum, they are saying, okay, go back to the descriptive, the basic of statistics, descriptive statistics, and predict your risk based on the historical data that you already based on the historical data that you already have. And there is something very interesting that you're going to learn now. Now, we discussed this in detail in quantitative analysis, but don't worry, we'll cover it here as well. What is risk? What is risk? Risk is the deviation from the expected behavior. That is risk. What is risk? Risk is the deviation. You can write it down. The definition of risk, which is pretty important. Risk is not probability. Some YouTube guy is stating about that. Okay, risk is what? The probability. Risk is not probability. Risk is uncertainty. Uncertainty to what? Uncertainty to expected behavior or deviation from expected behavior. About finance, one stated, I would say that there are a lot of myths and incorrect assumptions are being floating about finance, how to calculate and what is the right way to invest and everything on YouTube and different social media platform. If you just support them, your financial knowledge would be as good as them only, and it would not grow. So it is very important that either you stick to some well recognized institute to learn finance. Otherwise, definitely your investment would look as good as people who are stating these incorrect or absurd opinion about investment. Experience does matter, I would agree, But experience without the proper knowledge of the maths, the science behind finance, is completely absurd and stupid. Okay, with that, deviation from the expected behavior. Okay, what is my expected behavior? What is the expected behavior of the stock? What is the expected behavior of the stock? The expected behavior of the stock I just stated is the mean. That is the on an average behavior of the stock, that it would fall around 2.5714. That is what my prediction is. Why this is my prediction? This is my prediction because that is the center of the data. That is the expected behavior of the data. But we also see that there is a risk involved in this stock. What is the risk? The deviation from this expected behavior. The deviation from the expected behavior. Now I want to calculate that deviation. Okay, sometime it is 3%. Okay, sometime it is 3%. Sometime it is minus 4%. Sometime it is 0%. Sometime it is 2%. Sometime it is 10%. Sometime it is 15%. And sometime it is minus 8%. I want to calculate the deviation. How would you calculate the deviation? You would calculate the deviation in a very simple way. What is the distance of this 3 from the 2.5714? That is the mean. What is the deviation from the mean? Sorry, this 2 should fall here. This is incorrect. 2%. What is the deviation from the mean? 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 So what is the deviation from the mean? On an average deviation. On an average deviation. If I do this, what I'll do? I will do 3 minus 2.5714, whatever the deviation. Then 10 minus 2.5714, that is the deviation. Then 15% minus 2.5714, that is the deviation. Then 2.5714 minus 2, that is the deviation. Then 0 minus 2.5714, that is the deviation. Minus 4 minus 2.5714, that is the deviation, right? And on an average deviation, then I sum all the deviation and divide it by what? 7. See but what will happen? Understand what will happen. I'm saying my entity, each entity is x, xi. This is my x. Okay. So x1 is 3, x2 is minus 4, x3 is 0, x4 is 2, x5 is 10%, x6 is 15, x7 is minus 8%. Minus mean. What is my mean? 2.5704. Sum it up, divided by the number of entity, that is n, 7. That's my answer. But there is a problem. There are two problems. The problem is we are trying to find out the risk not for the stock K. We are trying to formulate a formula for all the stocks in the world. And if I just do this xi minus mean right now and to find out the risk, what will happen? This is positive, this is negative, 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 right? And when you sum it up, there is a possibility that your summation would give you answer 0. But what does it mean? It means that the risk is 0. But that's not correct. Risk is not 0. And because the risk is not 0, you have to formulate the formula in the right way. And this formula is definitely going to give you the risk, which is 0. On an average deviation from the mean is 0, which is not correct because you see the deviation. So there are two ways you can do it. You take the modulus and it becomes mean absolute deviation. Okay, that is one way. That is the formula of mean absolute deviation. Or you can do something interesting. You do the square. And it becomes the formula for variance. Why? Why we are not using mean absolute definitely you want to use mean absolute deviation, it's your choice. But when you study statistics, quantitative analysis, you would understand the best measure for risk is standard deviation or variance. Best is standard deviation. But we'll talk about why we'll not use variance. Right now I'm writing the formula for the variance. Variance formula is what? Xi minus mean whole square upon n. That is what the variance formula is. Right? Why have done square? There are two reasons for this. One, you have understood that I want to make something negative positive. But I also want to assign weight to anything, any risk which is more than other risk. What does I want? What does this mean? What I want to say? 15% is a higher risk than 2%. 15%, the deviation from the mean 15% is higher than the 2%. We understand that. And the 10% is higher than the 3%. We understand that. We want to assign higher weight to higher distance or higher deviation from the mean. I want to assign more weights to it. How would I do that? Either I will just not do the square and I just write weights and then from somewhere I will get the weights. Or I can just simply say the distance itself is the weight. And when I say the distance itself is the weight, then I'm saying this weight is what? This weight is this weight is xi minus mean. That's it. That's what my weight is. And therefore, the Venus formula would look like xi minus mean whole square upon n. That's it. That's it. And that is the formula for the variance. But there is a problem. When you do 3 minus 2.574 percentage whole square, the answer would come at the end in percentage square. So what do you need to do? You need to take the under root. So what it will become? It will become the formula of standard deviation and the square won't be there. So you're solving a lot of problem with the help of standard deviation, and therefore the best measure in the world right now to find out the risk is what? Standard deviation. Is standard deviation. That's it. Nothing else. The best way to calculate the risk is what? Standard deviation. And what is the formula of standard deviation? It is written here. There are other ways to calculate standard deviation. When probability is there, you won't use the formula. Now we'll discuss about it in detail when we study quantitative analysis session 1. Okay? So for return, for expected return, you use mean. For expected risk, you use standard deviation. Let's calculate the standard deviation of this particular stock. What are the steps you need to do? Definitely your BA2 plus calculator is sufficient to give you or tell you how to calculate the standard deviation. But let's do the maths. Okay? So calculate the standard deviation for this number. Okay, let's calculate the standard deviation here. So first do x minus x bar, then you do x minus x bar whole square, and then you do the summation. Okay. So right now you're doing x minus x bar, sorry, not x bar, mu. So 3 minus 2.5714 minus 4 minus 2.5714. Then you would do 0 minus 2.5714. What are they? They are the deviation from these numbers, are the deviation from the mean. Okay, that is the intuition. 2 minus 2.5714, 10 minus 2.5714, 15 minus 2.5714, and minus 8 minus 2.5714. These are the deviation from the mean. Whatever it comes, what you have to do, you have to do square. So what you'll do, 3 minus 2.5714 whole square, then minus 4, I think it would come minus 65714 whole square, then it is just minus 2.5714 whole square, then it would be, I think, minus 0.5714 whole square. This I will keep it like this, 5714 whole square, then 15 minus 2.5714 whole square, and this would be minus 10.5714 square. Then you sum it up, you sum the value, and then you divide by the number of entities 7, and then you take the square root. That's how you calculate standard deviation, and that will give you the risk. Okay. For the assignment, you have to calculate the standard deviation of the stock. First, mathematically, what is written on the screen, and then you would calculate with the help of BA2 plus calculator. Okay. So in the next session, we'll use the BA2 plus calculator and try to find out what is the final value of this stock standard deviation. Till then, thank you.